let's get started on Chapter 3, Configuring Local Storage. In this chapter, we will look at hard disks and disk terminology, installing a disk, creating a volume, and shrinking and extending volumes. We will look at RAID 0, 1, and 5, dynamic disks, GPT partitions, virtual hard disks, storage pools, and storage area networks. When we plan server storage, one question we ask is, how many servers do I need? If we have a very small company, we might have only one server and that acts as the print server and the file server and even the login server. But as a company gets larger, we would typically have many servers and have one role for each server. Each server would be a dedicated server. And then if the company got real large, we might get a large blade server and then run the servers as virtual machines under Hyper-V on the blade server, and we will talk about that in the virtualization part of the course. When we estimate storage requirements, the operating system and the roles and applications and paging files and log files really don't take that much space. What's really going to drive our storage needs is going to be based upon the number of users and the size of the company. Now, if we want to have fault tolerance, that is to say disk mirroring, then that will increase our storage requirements by a factor of 2. So the minimum storage, the minimum hard disk size is 40 gig, but the real size is going to be driven by the size of the company and the number of the users. Let's do a review of disk terminology. What's the difference between a hard disk, a partition, and a volume? I think everybody knows what a hard disk is. It's a mechanical device that we save data to. But if we look at this diagram here, it's really not clear to me the difference between the hard disk and the partition and the volume. Well, we know the hard disk is the physical device that stores the data. But in this case, it's not clear the difference between the hard disk and the partition. But if I take this hard disk and I divide it into 2 partitions, you can now see that a partition is a part of a hard disk. And I might want to save all my program files on one partition and all my data files on the other partition. But if you look at this diagram, we still can't see the difference between a partition and a volume. A volume is the thing that gets the drive letter, and in this case there is no difference between the partition and the volume. But when we look at disk spanning, when we take one disk, one logical volume, and stretch it across 2 partitions on 2 disks, we can then see the difference between a volume and a partition. A partition is a part of a disk. A volume is the logical entity, the thing that gets the drive letter that might occupy just one partition, or it might be spanned across multiple partitions on multiple disks. Hard disk, partition, and volume. Now let's look at different disk technologies which are available to us. PATA, SATA, SCSI, and SAS. We'll start out with PATA, Parallel ATA, which is also known as IDE, and we really don't see that so much on new computers. It's used on older computers. And PATA runs at 133 megabytes per second, and at the time we thought that was pretty good. And with PATA, the hard disk connects to the motherboard by way of a data cable. Well, notice on this data cable there is another connector here. That other connector can be used if we want to add an additional hard disk. If we add the additional hard disk and connect it to the connector, we have 2 hard disks sharing one single cable. And the question is, how does the operating system know which hard disk is which? And the answer is, we must configure one hard disk as the primary and the second as the secondary. We do that with jumpers, which are on the back of each hard disk. If we look at the back of the hard disk, we can see that jumpers are connectors which we can move from one position up to the other. So we can configure one hard disk as the primary and the other as the secondary. And if we configure both as primary or both as secondary, it's not going to work. That's PATA, Old Parallel ATA. SCSI stands for Small Computer Systems Interface, runs faster, 160 megabytes per second. And if we look at SCSI, we can see that there can be up to 8 SCSI devices in one SCSI chain. So an HBA is a host bus adapter, and that's a controller card. You could call it a hard disk controller card if you want, but they call it a host bus adapter. And a cable comes off of this host bus adapter, and other SCSI devices can connect to the host bus adapter. These could be typically hard disks, SCSI hard disks. They connect on one single SCSI, what they call a SCSI chain. So you can have 8 devices on a SCSI chain, but you have to remember that each device must be configured as device 0 through device 7, and the way you do that was with jumpers on the disk. So just make sure you don't have any 2 devices that are both configured as device 0, because then neither one will work. Now SATA, Serial ATA, is on most new computers, and Serial ATA is great. Not only is it faster, 1.5 gigabyte per second, but you don't have this confusion with the jumpers. There is just one cable per hard disk. You don't have 2 computers sharing the same cable. With Serial ATA, the hard disk has one cable that goes to the motherboard, so you don't have any of this confusion of configuring the disks. No jumpers on the disks. SATA is great. Now, SAS, Serial Attached Storage, is what we're going to see on medium and high-end systems, and Serial Attached Storage has much higher rotation speeds, which means greater throughput. If we look at Hewlett-Packard's SAS hard drive, we see it runs at 10,000 revolutions per minute, giving us a throughput of 3 gigabytes per second. So this would be on more high-end systems. So old PATA, not really used that much, SATA, SCSI, and SAS. Of course, once it's installed, it really doesn't make much of a difference to you when you're working in Windows, because when you're working in Windows, the procedure for creating and deleting and formatting volumes is the same for all of them. Now let's look at adding a physical disk. When we say physical installation, we mean take the top off the server and put in the disk and connect the data cables and the power cables. Then you turn it on, and then you have to initialize the disk. This is where the operating system recognizes the disk. So after you put the physical disk in, you then go to Server Manager, and then in Server Manager we go over and we select Tools, and under Tools we select Computer Management, and of course this is just like the Windows 7 Computer Management console, and Disk 0 is the one that was already in there, and that's got the operating system on it. We just added Disk 1, and noticed it is not recognized, it is not initialized, so we have to initialize it, which allows the operating system to accept it, to recognize it. So to initialize, I right-click, and I select Initialize Disk. And then it says, for the partition style, do you want to select MBR, which is Master Boot Record, or GPT, Globally Unique Identifier Partition Table? For the moment, we will take MBR, the Master Boot Record. That's the default. We'll talk about GPT later. I click on OK, and now we can see that the disk is just a basic disk, and the space on it is there, but it hasn't been allocated. So now what we need to do is to allocate the space and to create a new volume. So to create a simple volume, which is a volume which is only on a single disk, we go to the Computer Management Console, and where it says disk number 1 under our unallocated space, we right-click and select New Simple Volume. I select New Simple Volume, and it says this wizard helps you create a simple volume on a disk. A simple volume can only be on a single disk. I click on Next. It says how much disk space do you want to use. In this case, I will use the entire disk space. It's kind of a small disk anyway, only 10 gig. So I click on OK. It's typically going to assign it the next drive letter. I can assign it any drive letter that I want, but for the moment I will just accept the next available drive letter. I click on Next, and then it says, do you want to format it? Yes, we do want to format it, and the file system that we're going to select, we will usually, almost always select NTFS, the New Technology File System. That allows us to assign different users, different permissions to different files. Now we could use old FAT32, File Allocation Table, 32-bit, but we would just use that for backward compatibility with older computers. We would typically not use FAT32. Now the resilient file system is something new with 2012 server, and it is more resilient to errors on the disk, but that's a more advanced file system that only works with 2012 server. It's not backwardly compatible, so we will select NTFS. Almost always you're going to select NTFS. We click on Next. I will do a quick format. If I don't do a quick format, it takes longer, but then it does error checking on the disk. And I will give it a volume label, and it'll be called data volume, because the C drive had the operating system on it. So this volume right here is for storing data files. And then I click on Next, and then it says you're going to format as a simple volume, and I say OK, and I click on Finish, and then there it is. So now it is formatted as our new E drive. And then if I go to look at that by going to the Windows Explorer, I can see there is the existing C drive, and there's the DVD, and here is the new volume which we just created. And if I right-click on that guy and select Properties, I can see that no space is being used on this volume because we just created it. Extending and shrinking volumes. In the previous example, I created a volume which occupied all of the disk, but you could create a volume that only occupied half of the disk. But if later on you changed your mind and you wanted to occupy all of the disk, you could stretch it out, and that's called extending the volume. To extend the volume, we right-click and select Extend Volume. We specify the space that we want it to take, and I want it to extend to the rest of the disk. I click on Next, I click on Finish, and that's it. I've taken this new volume and I've now stretched it out to occupy all of the disk. Conversely, if I didn't want to do that, and I only wanted the volume to take half of the disk, I could right-click and I could select Shrink Volume, and I could enter the amount of space by which I want to shrink it, about half, and I click on Shrink, and that shrinks the volume back down. So in basic disk installation and volume creation, you initialize the disk, then you create a new simple volume. You specify the size of the volume, the drive letter, typically formatted as NTFS, and then you can save data to it, and if you change your mind on the size of the volume, you can shrink it or extend it as necessary. And this concludes part 1 of Chapter